So, hello everyone. Very nice to have you in this webinar, which is actually the fifth webinar that we are organizing on the topics of the use of remote sensing data for, I would say, sustainable development in Africa. I would say that is the broad topic of our webinars. So we had webinars already dedicated to the topic of hydrology, forest monitoring, landslides monitoring, and also mangrove monitoring. And so today the webinar is dedicated to the topic of observation of continental water, and more precisely on the topic of surface water quality. So we have the great pleasure already to welcome Charlotte EMERY from CNES and Tristan HARMEL from Magellium, which is a company in France, specialized in remote sensing. So first, let me introduce Tristan and Charlotte. So Charlotte is a hydrologist specialized in space hydrology and data. She's been working at CNES for almost 1 year now. But she has an expertise which spans hydrological and hydraulic modeling, as well as satellite data assimilation into these models, with a particular focus on the SWOT mission. Maybe you heard about the SWOT mission, which is a NASA CNES mission dedicated to the monitoring of continental waters. Providing altimetry data, but not only on continental waters, but also on oceans. So this was the topic of the PhD thesis of Charlotte. And now at CNES, she's being involved in several projects centers on the hybridization, production, distribution, and valorization of products designed to monitor the continental water cycle using satellite data. And one of her key responsibilities includes serving as the thematic lead for HydroWeb Next, which is the CNES platform dedicated to the dissemination of space hydrology data. And so she also oversees the OBS2CO chain, which will be presented to you today. And which extracts water quality parameters from optical imagery. But first we will have a first talk from Tristan HARMEL, who is an atmosphere and aquatic physicist specialized in applied optics, radiative transfer modeling, and remote sensing. He's working on the full nature of light within the Earth system, and his research has been focused on exploitation of the polarization of light for ocean remote sensing. So based on satellite sensors, which are providing multi-directional data, he has developed several algorithms for estimation of aerosols, surface winds also, phytoplankton, as well as dissolved and particulate matter in presence in ocean, coastal, and inland waters. So with the aim of understanding the intricate relationship between light and matter, part of his work is dedicated to prototype development and laboratory experiments to analyze and document optical properties, including polarization of natural and artificial matter. Welcome to you, Charlotte. Welcome also to all the participants who have joined this webinar. So we will have different parts in the webinar, and we will take some time between the different parts to receive questions. So please feel free, don't hesitate to ask questions in the chat. And so now it's time to give the floor to Tristan. Thank you. Tristan, please go.
Okay, thanks a lot for this introduction. So we're gonna start with the next slide after the main title. So the webinar of today will be about how we can extract information about what we have within the water column. So mostly in lakes, rivers. We can also apply this kind of techniques to ocean waters, coastal waters, estuaries, lagoons, many things. But here we will focus on inland waters, and we put here a nice illustration.
we lost Tristan. We lost
Yes.
him. Oh, sorry.
Maybe he has a
Yeah, some connection issue maybe.
So let's wait.
Let's wait a little bit.
Interesting is to have
Tristan?
this kind of hyperspectral data. Okay, so maybe we can, after this introduction, we can start the main presentation. So you can go next slide. Okay, so Charlotte, you wanted to give us the content of the webinar?
Yes, definitely. Yeah. So our talk is divided in 4 parts. First, Tristan will present you the science over how to extract water quality parameters from space and how to validate those products. And on this, then we
left, you have still what we call the sun glint, so the reflection of the sun on your water surface. And after the correction, you can see that you removed all the contribution for this sun glint, and you get really what can inform you about the water quality parameters. Okay, you can go next slide. Okay, so that was the processing of a satellite image, but we can do the same kind of measurements from the field, which is very important for all this research about water quality, to get measurement of light from the field. And to do this, we have different setup. Actually, I put just a few here. The first one, which is commonly used by the community, international community, by different researchers, is based on radiometers. You can have like this. So here it's from a German brand called Ramses. But you have a full document that I put the link in the fiduciary reference measurements for satellite ocean color. Ocean color could be lake color or river color. Okay. And here you will measure the light from the sun, okay? So from the atmosphere, so that's the one vertical. And afterward, you will measure the one from the sky and something pointing to the water. And with these three measurements, you can have what we want, which is the reflectance of the water column, okay? So that's the first measurements. We can do like this. Afterwards, if you get the CMEL separation radiometer, this one is a multispectral one. Used to be exploited for aerosol first, to monitor the aerosols worldwide. So you have a very dense network called AeroNet over the world to monitor the aerosols. And one component of this network is called AeroNet OC, okay, for ocean color. And here you will do the measurements of with robots. You will move the arm to get the sky, to get the water, etc. But it's multispectral. Right now we have a new one for another network used for calibration and validation of satellites, which is called HyperNets. And you have a water component of the network. And here it's a picture of the HipStar sensor, which actually is also with a robot. So you can move the cylinder here, and you can do the measurement of the downwinning irradiance, so all the light arriving at the bottom of the atmosphere, and proceed with water measurements, sky measurements, to have all the information we need. And it's hyperspectral, okay? And the last one I put, it's something very new. It's here it's coupling two different systems. One with a radiometer, so you have as the other ones a passive measurement, which means that you just collect the photons from the sun reflected back to the sensor, and this system is coupled with a LiDAR, so with a laser that will highlight, illuminate the water column, and you will get also the light scattered back to the sensor, and you will be able to have another measurements of the water quality parameters from light. But the thing of interest here is you can do the measurements during daylight, of course, but also during night. So here with this kind of system, you have something that could be linked to the satellite to validate satellite, but you have complementary data 24 hours to have a high frequency time series to help interpret also the different phenomena you will have from the snapshot of the satellite image. Okay, can go next slide. And based on these in situ measurements, you will be able to validate the full processing chain I showed. So the atmospheric correction is something we need to retrieve different parameters. So we have uncertainties in it. Sometimes it can be a failure within the algorithm, I don't know. So you need to make this kind of validation. And for this, we need to have in situ data. So that's why it's something very important to have in mind that for a given country, we need at least a few radiometers to do the validation if we want to use safely and for regulatory purposes the satellite images. Okay, so here just to show you that we have good comparison between what is measured from the field. So here on the left, it's measured from the ARNet system, so it's multispectral, so you can get the different spectra with the colors and dots. And on top of it, you have the hyperspectral data from Prisma satellite. Okay, so that was done recently for an exercise we recently published with an international comparison of different atmospheric correction. Okay, and on the right you have the same thing, but when you take the value from the in situ data, so it's the x-axis, and you get the value from the Sentinel data, satellite data, sorry, and you do the comparison. So normally you have to get a 1-1 line, because you should have exactly the same thing from the in situ and from the satellite, but actually, as always, you have uncertainty is in situ data, uncertainty in satellite data. Sometimes it's not exactly the same time of acquisition. You have something like these big pixels with the satellite and very narrow dots, narrow footprints for the in situ. So that's why you still have uncertainty, but it's something we need to take into account to proceed with the validation and performance analysis of your satellite imagery. Okay, you can go next slide. Okay, so if you have any questions, just please interrupt us.
So I will ask my question. I was wondering.
Yeah, something important here, the OBS2CO water quality product are produced within the TEA data hub. And so it's based on the Sentinel-2 product, and we don't produce and distribute the full global coverage of Sentinel-2. There is a fixed production mask that is given here on the slide. So it covers mainly Europe and some region in Africa, South America, and India also. And if at some point you are interested of getting those products over new areas, you can reach out to TEA directly. So I think I will put in the chat the webpage where it guides you on how to ask for more tiles production. I will put it in the chat when I'm done with my talk. And you can like make a request, and TEA will, I don't know how it works exactly, but they will give the production center indication to add some tiles or not. Yeah, and you can go to the next slide, and I think I'm done for HydroWeb Next, and maybe this Aqualytics platform, Tristan, you know more about it than me, so maybe you can take over here.
Yeah, thanks, Charlotte. So Aqualytics, it's something dedicated to Europe, but it's for the moment it's kind of demonstration for the European Space Agency how we can produce different water quality parameters. So as we remember, maybe we have the temperature from Landsat, and we have afterwards all the other parameters from Sentinel-2. So it is something a little bit connected to what Charlotte just showed, but here it's really to have specific project on given lakes and provide this kind of showcase of how we can use the data and how we can use it at the end to take decision for monitoring for managing the different lakes. Okay, so here you have the different parameters we are providing. So it's chlorophyll A, transparency, suspended particle matter, turbidity, surface temperature, and also the reflectances. It's something more for expert users to get the reflectances as the one distributed on the CNES website. But it's also something we are providing notebooks if you want to do your own algorithms. And sometimes, as we showed in Burkina Faso, it's nice to get back to this parameter and to retrieve and to do your own algorithm for your own given region. So that's why. So the spatial resolution, just to let you know, because it's different from temperature and different bio-optical parameters. So for Stel2, it's 20 meters. So it's the same as in HydroWeb Next, it will be 20 meters. But for Landsat, it will be 100 because the sensor is different for temperature. Okay, and here we have a limitation because it's not like having all the data as for the obstacle chain of HydroWeb Next. Here we have like like an extraction of the different lakes. So that's why we have this kind of recommendation for lakes and river. And we need, for example, we deliver the data when the lakes are greater than a given size. And for the rivers as well, we need to have width, minimum width to provide the data. Okay, and we have weekly updates. So it's okay. So we can go to next slide. And here the thing is to have it's really the objective of this platform. It's not to make a replacement of the HydroWeb Next, but to prepare the next generation of HydroWeb Next, the HydroWeb Next. It's to provide dashboard and tools to have an analytics of the parameters. And here it's an example when you get a lake, you have the statistics of one given parameters. If, for example, you take the temperature, you have your time series for this given lake. Okay, so that's the main goal, is to get into these dashboards facilities. Okay, I don't remember what we have afterward. But... Okay, and so that's the let's practice. And because I think we will conclude on it. So that's just to let you know that we have this kind of prototype to make analytics of the water quality data from a web portal. So you have the link here, but because it's a European project, we have nothing in Africa yet. But of course, we are very interested by knowing if you have interest in it, if you want to apply for a case study in your country, or this kind of things. Okay, and because it's we are reaching noon, I think we will have to close the session.
Yes.
So the thing for the last part, it's just to provide you with the links if you want to get into more details. Okay, so it's the let's practice one. So here we have the links. So from Charlotte. So if you want to talk, just interrupt me.
Yes.
It's okay.
Yeah, it's fine. I can take over. Yeah. So very quickly, because the OBS2CO product are based on the Sentinel-2 tiles, you might want to get those tile polygons, so you can access them from HydroWeb Next, but you can also find them on Copernicus. So those are the same file. Next. Yeah, so a few links. If you want to come back later on those slides, you can find some nice illustration on following those links. Next slide. And then a bunch of tools, online tools, virtual research environment, if you want to play with all those data before getting to use them. So you have some Jupyter notebooks, you have some portals, and we also give you all the documentation for the code that are used to produce those OBS2CO products. And I think we're done. If you go to the next slide, I think is the thank you slide. Yeah. So
Okay.
thank you. Thank you.
Thank you very much, Tristan and Charlotte. It was really interesting and very comprehensive presentation, and it's very nice to have also all these scientific explanations and all the explanations related also to the physical phenomena. And so thanks a lot again. I know it was a huge work preparing all these slides. So we have recorded the webinar, so of course the replay will be available to all the people who have registered and who could not attend today, unfortunately, but also you will get the link if you want to use the replay of the webinars for your use also. I don't know, I guess the explanations regarding HydroWeb Next, they can be also made available on the TEIA platform or something like that. So thank you very much again. Just maybe one last information for our participants is that we will have a webinar May 19th dedicated to One Forest Vision initiative. So stay tuned, and so thank you again. And so I don't know if there are any questions, but it was a rather long webinar. So thanks to all the participants who stay connected all the time. But I think it was really, really valuable to get all this information. So I think it will be the last word. Okay, so wishing you a nice weekend ahead, and thanks again.